In this video, we're going to talk about how we can use the Poison Ivy remote access Trojan in order to attack a target. Now, before we get into the remote access Trojan, let's specifically talk a little bit about what Poison Ivy is and kind of why it might actually exist today. One of the things that you'll utilize a lot in an IT realm is remote access tools or remote admin tools. Now, these remote administration tools, in theory, should be able to allow you to do everything on the remote machine that you would be able to do locally. Not only would it allow you to do it remotely, but it would allow you to do it with highly elevated permissions. That's the whole purpose of an admin tool. Basically, you'd be able to install software, remove software, copy files, start and stop services, add permissions, and even remote control the desktop. That's kind of how the idea around Poison Ivy and other remote administrative tools started coming around. By utilizing these remote admin tools in a somewhat malicious format, a very malicious format, takes valid tools and turns them into hacking tools. The tools are perfectly legitimate and there are perfectly good reasons to keep them. However, hackers have made them do things that they weren't initially designed for. Eventually, hackers developed their own tools based off of the same idea, such as Poison Ivy here, which was an extension from a remote admin tool. But still, these types of tools can exist for legitimate reasons. Additionally, legitimate tools can then be used for illegitimate reasons. So if we look at our network diagram here, what we're going to be doing is we're going to be working on two different machines. One of them is this Windows XP Pro. This is our target. This is the machine we are going to attack, and we are going to attack it with a Trojan. The machine we're going to be attacking from is this Windows 7 machine. So we are going to use the Windows 7 machine to go through the firewall and attack the target. There's going to be a couple of different things we're going to be doing here as far as one, using Poison Ivy, two, configuring that as a Trojan so that it will look like it's something that it's not, and then three, using a little bit of social engineering in order to get our tool to work remotely. So let's go ahead and get started. Before I get in very far, however, I do actually have to go over to this Windows 7 machine. In my environment, the way it's snapshotted right now, the network card is disabled. And so I need to go in there before I do anything, and I need to enable that network card. So I'm going to go ahead and log in here, see password. And let's go ahead and look at my network here. And actually, is that right? If I run ipconfig, yeah, that's the wrong network card. So enable. Okay. Public, yes. One more time, ipconfig. And there we go. Now I can see I do have a network address of 216.5.1.200. That's exactly what I wanted. That's better. Even better. Okay. So there we go. I see I've got my network address and I am set to go. All right, so first off, let's look back from the Windows XP's point of view. I'm going to go ahead and log in as administrator, and my password is ethical hacking. There we go. what I want to do is I want to try some basic connectivity testing. Now, if we look back at our network diagram, the firewall here is going to allow some traffic and block some traffic. Because this is internal network that my XP Pro machine is on, I should be able to go out without any issue. Most business environments are set up that way. The firewalls are allowed to are configured to allow all inside traffic to go out. So if from this Windows XP machine, I tried to go ahead and ping 216.5.1.200, it should respond without issue. Perfect. Okay, however, if I look back at my Windows 7 machine, the machine I'm going to be hacking from, and I try to ping that Windows XP machine to 168.1.175, I should get simply a timeout. Basically, well, two different things. One, the firewall is blocking me. And then two, well, that's a private IP address, and private IP addresses aren't allowed on the internet. So it should be blocked, or shouldn't be allowed to go out through the internet anyway. But because we want to be able to attack that machine, we have to find a way to go through that firewall, which is one of the things that our tools will allow us to do. All right, so let's go ahead and look into this. Let's see, so I have a folder on here called malware. By the way, be very, very careful if you try to download any malware online. Make sure you're pulling it from the correct source. It's entirely possible that a malicious user has gone ahead and, well, done exactly what we're about to do and hidden their own malware inside of the malware you're downloading. So that not only are you downloading some malware, but you're also downloading their hacked version of it that they can then use to attack you. All right, so we want to look at Poison Ivy, and for that I have version 2.3.2, and so I'm going to right click on that. I'm going to use the tool called 7-zip in order to extract those files. While I'm here, I'm also going to eventually use this wrapper tool, so I'm going to do the same thing, 7-zip and extract. All right, so inside of my Poison Ivy file, I want to go ahead and launch Poison Ivy 232. Pops up with an end user license agreement, which is basically their way of saying, hey, if you do something illegal here, we're telling you not to. So if you get caught, it's your fault because we told you not to do this. So I'm going to go ahead and say, don't show this again because I've looked through this. I've glanced through it very briefly. I suggest if you're going to be using this beyond just a test lab, read through that, at least skim through, see if you understand the basic ideas, and then say, I agree. All right, so Poison Ivy is up and running. We're going to come up to File and New Client. Now this seems a little bit backwards of the client versus the server. Just go with it. So we've got the client. We're going to change the port that we're listening to 443. The reason why I'm changing the port that we're listening on to 443 is because, well, random ports are questionable, are concerning to security administrators. However, if they see traffic on port 443, they're gonna kind of assume it's just web traffic and ignore it. I could choose port 80 as well, but port 80 is oftentimes non-encrypted, and therefore if a security admin is looking through the traffic that's on port 80 and finds encrypted traffic, which Poison Ivy will generate, then they will be very concerned about what type of encrypted traffic is going over a non-encrypted port. So with that being said, I'll go ahead and click Start, and it is now listening. In fact, I can confirm it is listening by going to the command prompt. I can do a netstat-an. This gives me a whole lot of information. I could go through here and I could look for various ports. Let's see, port 443 right there. I see I've got a listening on port 443. And then also netstat-abn or ANB. And this will tell me the applications that are running. And if I look through here very briefly, we should be able to find poison ivy. Poison ivy executable right there, listening on port 443. All right, so we've got the application up and running, and it is listening. What we want to do now is we want to configure poison ivy for our Windows XP machine. Basically, we want to prepare our payload for our target machine. So for that, we come back to poison ivy, and we go up to File, and New Server. Again, what's a server? What's a client? It's a little counterintuitive, but in this case, this is the way it works. Let's see. So create a new profile. We can call this pretty much anything we want. It is more of a friendly name. I'm going to go ahead and call it Hacking 101. Sure. And then say OK. In the DNS and port section here, I want to go ahead and change this, and I'm going to change that to my machine that I am currently on. So 216.5.1.200. So basically, we're telling the server to go ahead and talk back to me. This could be a DNS name. Excuse me. This could be a DNS name or an IP address. In this case, we're using the IP address. The port that we want it to talk on, which is 443, and then 0 and comma. The 0 and comma, I believe, has to do with the session. The other options here, connect through proxy, hijack, we're going to leave those as is and just click Next. We then get to the install screen, or install settings, and I'm going to choose this Start on System Startup. Basically, that means if the computer reboots, go ahead and restart this again. If I don't select that, then what happens is when I infect the remote target, it will be working perfectly fine until that machine gets rebooted, and then I'll never have access to it. This right here allows me to persist and restart when the machine is rebooted. It does that by putting a registry key under the HKey LM, HKey local machine registry hive to automatically run on startup. I can name these registry hives or these keys under that hive whatever I want. So I might want this to be something common that an end user wouldn't notice. For instance, if I called this Internet Explorer. Or how about iExplorer? There we go. iExplorer. iExplorer, that's the name of Internet Explorer. Therefore, if somebody sees a name called iExplorer, they're at a glance, they're going to assume that is something completely normal and won't be too concerned about it. At least as a hacker, that's my hope. With that said, I'll go ahead and click Next. Brings up some information here on the advanced screen, the mutex, the injections. I'm going to go ahead and leave those as is and click Next. Here we can go ahead and we can choose an icon that we want it to run on, to look like. And so we can put an icon in here. We can put some optional settings in here. I'm going to leave those as is and just click Generate. As it generates, it asks me, great, what file do you want to create here? First off, where do we want to create it? I'll put it on my desktop. And then what do I want to call it? Well, I called the one registry key iExplorer, so I'm going to do the same thing right here. iExplorer. There we go. Very briefly, let's go back to the install. I forgot the R at the end. Let's try that one more time. Explorer. Okay. And when that's done, clean that up. We can actually see it's right there on the desktop. All right, and then lastly, okay, that goes away, and we see Poison Ivy sitting in the background, waiting for something to happen. All right, so the way this works, basically at this point, this is my malware. That iExplorer.exe is my malware. If I run that iExplorer.exe on any computer in the world, in theory, it should come back to this machine and would then show up in a list right here. In fact, I could send that file out to 100 different people, and if 100 people ran it, then I would have a list of 100 computers all right here in my remote tool that I can then remotely attack those machines. However, that looks a little questionable. If I saw a file called iExplorer.exe, especially with no icon attached to it, I would really be questioning what's going on. So we're going to Trojanize this. A Trojan, basically, it's a file that you think is something, but is something else. Goes back to the story of the Trojan horse. Oh yes, the Trojans have given up on attacking our city, and they left us this great present of a horse, a great big wooden horse. So let's go ahead and bring it on inside. And then when everybody's asleep, the soldiers crawled out of the horse and attacked everybody. We're going to do the same thing. We're going to send a gift to somebody. And it's going to look completely legitimate. And then when we're done, well, we're going to have enemies come out from the inside of the horse and attack the person. So we do that by coming back up to our malware folder here, and I'm going to be using the wrapper program. The wrapper program allows us to actually connect multiple machines together or multiple applications together as one application. All right, so we open up the wrapper program, and what we do is we just click this add file command on the right hand side. Add file, let's go ahead and choose our iExplorer file. So I'll click browse, back to the desktop. iExplorer. And okay, is that right? Yep, that's right. And when that's done, I will click add file again and browse. And in this case, there should be a file on my desktop here called putty. Putty.exe. And I'll say okay. And there we go. Now we've got both of these files together. So putty.exe, really quick. Putty is a really great remote tool, specifically for SSH and Telnet. If you ever have to remote into a router or a network switch or even some remote servers, SSH is the normal protocol you would use for that, and therefore Putty is one of the best open source tools in order to facilitate that. What this wrapper program is doing is bundling or wrapping Putty with our malware. When we're all done wrapping those together, what we'll do is it will be configured in such a way that once that file is executed, then both Putty and our malware will be executed together at the same time. So we do that by... That's interesting. There we go. For some reason, my buttons weren't showing up. By clicking select output, and basically what we do here is we specify which file we want this to be. To save me a step, I'm going to go ahead and put this in my C drive. Enter the inet pub and FTP root directory, and I'll call this SSH. When that's done, let's go ahead and confirm that that's there. CC inet pub FTP root. No. Make. I missed a button. Make. There we go. And now ssh.exe is up there together. And now when you run ssh.exe, it will run both of those applications. By the way, wrapper.exe, this wrapper program right here, nothing particularly malicious about this. This is a perfectly valid application that you would have. For instance, if you needed to install software, this might be one way to package the software for install so that multiple smaller executables or scripts will all run together at the same time. All right, so now we've got our malware. We've got our server set up. We've got our client set up. We've got our malware set. It's packaged together with a perfectly legitimate tool. So now it is a Trojanized environment. What we need to do now is we need to entice our target to actually run that Trojanized tool. And for that, we're going to use some social engineering. Social engineering we're particularly looking at is going to be email. Email is always fun. So I'm going to go ahead and open up Outlook here. Next, do you want to configure? Yes. I'm going to configure a POP account. POP, Post Office Protocol. Let's see, I'm going to go ahead and say I am director. My email, director at ceh.com. CEH, Center of Ethical Hacking? Certified Ethical Hacking. Excuse me. Incoming POP server. Yeah, sure. I'll go ahead and type in 216.111 and same for the outgoing. Password. Ooh, I did directory. Director. Password. Now that director and the password don't actually exist. I'm making them up. It's just something that we can do. Email is not always super secure. Therefore, we can oftentimes just make up our email addresses and make up our names. Particularly what we're doing here is we are sending an email to 216.111, which just happens to be this IP address here. Now, this firewall is configured in such a way to forward all traffic up there to that Windows 2003 server, which just happens to be running Exchange. That Exchange server, I can just simply send a message to it and say, hey, I am from some outside company, and I'm sending to one of your employees. So hopefully I know the name of an employee who's already in there. And as long as I can send to there, which then gets forwarded to the email, it should get redirected back into the target's mailbox. Now, this assumes that none of the latest and greatest anti-spam features are installed. If they do have anti-spam set up, then it takes a little bit more work to get this social engineering step to work, but it is still pretty much the same process. All right, so I'm going to go ahead and say next and finish. So now that I have all this set up, I'm going to create an email. Specifically, I'm going to send it to one of the users inside that company, rmiller@xyzcompany.com. Hopefully, I've already done some research. I already know a username, specifically rmiller. Along with that, I also know that he is looking for an SSH utility. Not only an SSH utility, but something to do with CEH, something to do with a certified ethical hacker or a pen tester or something along those lines. So let's go ahead and type him a message. I was thinking this SSH utility will really help you in your CEH studies. It's the best one I have found. And and it's open source. Now you can't send a file across the internet or across most email systems, so you actually have to send a link somewhere. I will send him a link to my FTP server, 216.51200/ssh.exe. There we go. And then sincerely, and whoever I am, currently I'm saying I'm the director of this certified ethical hackers. Now, before I click send, what I might want to do is read through this and make sure it's spelled right, make sure it all makes sense, possibly even add in some more context here so it does actually look like something that would come from a director at from the Certified Ethical Hacking Organization. Yeah. Because that's like step number one when you see viruses or malware coming into your environment or spam, is you look for typos in your emails. And so you want to make sure you don't have those yourself. Once you've confirmed that, go ahead and click send. And it's going to go ahead and send that email to my target. All right. So the only thing that's left now is I wait until the target opens the email. Let's go ahead and pretend we are that person and log back into that target machine. And I want to just open up email here. So this computer has email set up and it is already Reggie Miller who has logged in. And so when he opens his email, that message shows on up. All right. Well, hopefully, if we are good hackers, hopefully we have done some enough research on Reggie and enough social engineering with Reggie to know that this is actually a viable file for him or viable knowledge for him to use enough to be able to download and run this file. So we'll go ahead and download that. Save it. Sure, go ahead and save that to my desktop. Close. And there's the SSH file. If I go ahead and open that, sure, let's go ahead and run it. I trust the director from this Certified Ethical Hacking. And I look at it and I see, oh, this is putty. Yeah, sure. I've been working with lots of network tools before. I know a little bit about hacking, and therefore I know about putty. Yeah, okay, that's a great tool. I really didn't need to download it a second time though. So I look at that as Reggie and I'm like, yeah, okay, that's kind of pointless. So I close it out and then I continue on with my business. In fact, I close it out and I may even just delete that file. No, not a problem. Doesn't allow me to delete it. That might be questionable. It says the file might be in use. Okay, that could be concerning. Let's assume we didn't do that, and let's go back onto our attacking machine and see what we see from there. So if we go back to our Windows 7 machine here, let's go ahead and close our Outlook here. We're done with email. We're done with our social engineering. Let's close the wrapper. We're done with that. Nope. Let's close our iNet pub. We're done with that. But back in Poison Ivy, we see we do in fact have a line, a server that's connected to our Poison Ivy client. We can get a little bit of information to see the ID hacking 101. That's the ID I typed in. Its WAN address 216.111. Again, that's the firewall we're connected to. The LAN address that's behind that 192.168.1.175. Its connection type, we're not going through a proxy server, so it's a direct. The computer name, who's logged in, what type of admin access they have, whether it's just normal user, guest, admin. The operating system, the speed of the CPU, the RAM, and so on. If I go ahead and I double click on this, it opens up a window to where we can see more information about the environment. So let's go ahead and look through some of this. Right now, information is selected. If I right click on the right hand side here, right click and say refresh, it gives me various information about the system. Such as the OS, the edition, computer name, and so on. Okay, that's kind of interesting. It's not super useful. Let's see what else we got. We've got files. Let's go ahead and right click and refresh. And I see, yes, an A drive, a C drive, and a D drive. Let's go ahead and look at the C drive. And there's all of the C drive. That's kind of interesting. Not only do I have the C drive, but I can start browsing through here. documents and settings, administrator. Let's look at the desktop. And I can see there's the SSH file I had just copied. I can also, if I right click on here, I can upload new files. So if I say upload, I can go ahead and choose from my desktop pretty much any file I want. I'm just going to choose a random SQL.txt. At this point, I am uploading that SQL.txt file, and if I right click and I say refresh, we'll see that it's there. If I'm really concerned, I could actually go over to my machine here, and I see there's my SQL.txt right on the desktop. There we go. So not only can I upload files, I can also download them. So I can download them, I can delete them, or if they're executable, I can say go ahead and run it normally or run it hidden. I'm curious, if I click this and I say run normal, it asks me if I have any parameters that I want to go with it. I'll say none. And then we go back to the computer and it says, hey, you're trying to run some files. Yeah. So if that warning wasn't there, that would have just gone ahead and run without any question. All right, what else can we do with this Poison Ivy tool? Well, there's the Registry Editor. Remember, we just talked about the run command in order to make this application persistent. That's going to be under the HKey local machine, software, Microsoft, Windows. Is it Windows or Windows NT? I think it's Windows NT, current version, and eventually we'll find a run. No, might have just been Windows, not Windows NT. Current version, run, and there's our iExplorer that we had configured for this machine. So it will be persistent throughout the next reboot. So that's Registry Editor. Again, I can go ahead and I can edit these. I can go ahead and modify them. I can create new keys. I can delete these keys. I can rename these keys. Pretty much full admin access from the other side of the world, possibly. Processes. I can go ahead and see which processes are running on this machine and go ahead and kill them if necessary. For instance, putty.exe, I can go ahead and kill, and that will end on the remote machine. See services. I can see what services are running. So here I can see all the services that would show up in the normal services management tool. Let's see. I can find any service in here, such as the Windows Update. Automatic updates. I can see it is currently running. If I right click and stop, I am now just stopped the updates. Let's see, I think I have to refresh this in order to see it. Automatic updates currently stopped. I can also change it. Edit. I can change the startup type from automatic to manual to disabled. So I set that to manual, which means automatic updates won't automatically run. If I was a hacker, if I was a penetration tester, this would be a great place to be looking for an antivirus. I go ahead and find the services that configure antivirus, disable them, and set them not to run again. Let's see, installed applications. I can go and see which applications are installed. And then Windows, which Windows or which applications are currently running on the remote machine. Let's see, anything else? Yes, remote shell. Ooh, here we go. Go ahead and get a remote command prompt onto the machine. That's helpful. Password audit. I can go ahead and look at the NTLM hashes. Go and right click refresh. Here I'm able to see all the usernames and all of their LM or NT hashes. Once I have these, I can go ahead and click save to file and then try to hack those offline. Additionally, I can go ahead and do a screen capture. Yeah, screen capture. Go ahead and capture everything that they're doing as they're moving around on the screen. Similarly with webcam, if there was a webcam attached to this, audio, and a keylogger to capture any passwords that they are typing in as they're going. So there we have it. That is the Poison Ivy remote admin tool. Excuse me. Remote access Trojan. And how we would be able to use that in an environment in order to attack a remote machine. Now, again, these may have legitimate reasons to be used in some environments. However, they're also somewhat illegitimate reasons. Therefore, you have to be a little careful, especially with your firewall, of what type of traffic you're allowing through the firewall. In this case, we're running against port 443. So most firewalls that are non-next-gen firewalls, most firewalls that are not intelligent and capable of decoding SSL packets would not catch this type of traffic. It would just simply see that there is traffic, encrypted traffic going across port 443 and allow it to go through. As you saw, it was a piece of cake to be able to set up. The Poison Ivy process itself was pretty easy to set up. We then bundled that together with a viable application, a perfectly normal application, in order to Trojanize it. And then lastly, we used some sort of social engineering. In this case, it was email. We could have used a lot of other social engineering techniques, such as sending messages through social media, or physically attaching a USB drive, or dropping a USB drive in a parking lot in order to get the file on the computer and executed.